This video is not about just learning the solution. It's about learning how to make small cumulative steps to give an exact solution. To all my audience, I'll tell you once again that brain decides which information to retain and which to forget. So what you have to do is, you have to repeat everything over and over again so that your brain is able to retain most of the information that you have given. So, your consistent practice will lead you far ahead from where you are right now. This thing, please keep it in your mind and please move on to today's topic, that is conformal transformation or conformal mapping. So, today we are going to solve problems related to bilinear transformation. The first transformation is determine the linear fractional transformation that maps z1 is equal to 0, z2 is equal to 1 and z3 is equal to infinity into w1 is equal to minus 1, w2 is equal to minus I and w3 is equal to 1. So this transformation is called Cayley transformation. And next one, the second question here is find the bilinear transformation that maps 0, 1, infinity in z plane into minus 1, minus 2, minus I in w plane. So here for bilinear transformation, we have to remember the formula. See here, generally Z1, Z2, Z3 are the general points in Z plane and W1, W2, W3 are the image points of these Z plane. So here for the bilinear transformation, so how to remember this one? So please apply Z on both sides. First of all, we have to take first 4 points and we have to see here, frame the formula here, that is Z minus Z1 Z2 minus Z3. So first we have to take the 4 points in the numerator and later we have to shift the 4 points towards this Z1, Z2, Z3, Z. See in the denominator Z1 minus Z2, Z3 minus Z. So this is how that easy, so which you can easily remember. So first of all consider these 4 points W minus W1, W2 minus W3 in the numerator and next one later these 4 points W1 minus W2, W3 minus W. So this is the unique bilinear transformation from the textbook itself and see here we can apply any points in these bilinear transformation formula so that we'll be getting the solution very simply. First thing here is, so first problem here is determine the linear fractional transformation and there is one more point here, bilinear transformation is same as linear fractional transformation. So if it is asked as a linear fractional transformation, we have to apply the same formula as bilinear transformation. Don't get panic. So this is linear fractional transformation is also known as bilinear transformation. See here, as you know, that so these are the points here, so the points are also very simple, that is 0 comma 1 comma infinity in the z plane and minus 1 minus I 1 in the w plane. So here every time, so we have to consider this as a z1, this is z2 and this is z3 and this is w1, this is w2 and this is w3 and now we have to consider one z this side and one z that side and here w also. First of all I'm taking these 3 points here. So here the formula is also so simple. In the numerator we have to consider this is Z, Z1, Z2 and this is Z3. In the denominator we have to consider these 4 points, that is Z1. So this is Z2, this is Z3 and this is Z. So this is how we have to write the formula in an easy way to remember. See here, first of all, I'm taking these 4 points, that is W, W1, this is W2, W3 and later, so I'm considering these 4 points. So here from W1 we have to start W1, this is W2, this is W3 and this is W. So this is how we have to remember the formula here. So this is so simple. So you also practice and learn and definitely you will be getting a solution. So first thing here I'm applying Z1, Z2, Z3 values as these are Z1, Z2, Z3 values. So here, so this is the thing, that is Z minus 0 and next one this is 1 minus infinity here and in the denominator 0 minus 1. So this is 0 minus 1 and this is infinity minus Z. Clear? And here also the same thing, W minus, what is W1? Minus 1, minus of minus plus 1. This is minus 1, this is minus 1 and here in the denominator, so we have to consider from here this is minus 1 minus, so this will be minus I, and next one, this is 1 minus W. See, every time we have to write Z in one side and W in one side. So Z minus 0 is Z, and this value is minus 1. Clear? And next thing here is also, this is 1 minus infinity and this is infinity minus Z. And here I am writing W at one side, that is W plus 1, and here if I take minus, so W, this is minus 1. Here if I take minus here, this will be 1 plus I, and here this, if I take minus common, this is 1 minus I. Clear? And now I can cancel this one, I can cancel this minus and this minus, and now see here, this is a Z by 1, and now I am applying infinity, limit n tends to infinity, so this is 1 minus n by, this is n minus Z. In place of infinity I am writing n, and the next thing here I am writing as it is, as W plus 1 by, this is W minus 1, this is 1 plus I by, this is 1 minus I. Clear? And next one, if I apply in place of n as infinity, so this will be infinity by infinity. So this will be infinity by infinity. Now I am going to apply the L'Hospital's rule. So if it is infinity by infinity, I am going to apply L'Hospital's rule. If I apply L'Hospital's rule, see here, if I apply L'Hospital's rule, then I have to make a derivative with respect to n. So with respect to n, 1 will be 0, and with respect to n, this is 1, and next with respect to n, this is 1, and the rest will be 0. Clear? So here, before that one, so we have Z minus 1, so this is W plus 1 by, this is W minus 1 into, this is 1 plus I by, this is 1 minus I. So clearly this is Z times of 0 minus 1 is minus 1, this is plus 1, and this value is W plus 1 by, this is W minus 1 into, this is 1 plus I by, this is 1 minus I. And clearly, see here, if I send this term to that side, so this will be minus Z times of. So if I send, this will be in the numerator and this will be in the denominator. Now if I rationalize, so if I multiply with 1 minus I into 1 minus I, see here, so if I rationalize, then see what happens, is equal to, this is W plus 1 by, this is W minus 1. So each and every step I am vividly explaining, please practice definitely. So it will be very, very helpful here. So this is 1 minus I for 2 times. This is 1 minus I whole square. And this is A plus B into A minus B. So this is A square minus B square. And this is again W plus 1 by, this is W minus 1. So if I expand this one, this is A square plus b square minus 2ab, and this is 1 square is 1, I square is minus 1, so this will be plus, and this value is W plus 1 by, this is W minus 1. So as everybody knows that I square value is minus 1, so I am applying here in place of this as minus 1. Therefore this is 1 minus 1 minus 2I by 2, which is equal to, this is W plus 1 by, this is W minus 1. So I can cancel these two. I can cancel even this 2. Minus into minus, this is plus. So this value is Zi. So what is left over here? Zi is left over, which is equal to W plus 1 by, this is W minus 1. So I need the value of W. So here I am applying componendo and dividendo. So this is componendo, and so this is dividendo. So this value I can write it like this. For componendo and dividendo, if there is a fraction here, so we have to make an addition for one time and we have to make a subtraction for one time. So that's what I'm applying here. So this will be Zi plus 1. So this will be Zi minus 1. So here this will be W plus 1 plus W minus 1. Here this is W plus 1. If I make a minus, so this is minus 1, this is plus 1. So plus 1 minus 1, this is plus W and minus W. So this value is Zi plus 1 by, this value is Zi minus 1 is equal to 2W by 2. So if I cancel, so here our W value is equal to Zi plus 1 by, this is Zi. So this is Zi minus 1. Still, if I multiply with I here, plus I and minus I, and see what happens here. So this value is going to become, so if I multiply zi square plus I by, so if I multiply, this is zi square minus I. As you know that I square value here is, I square value here is minus 1. So I square value here is minus 1, and therefore W can be written as minus Z plus I, and here minus Z minus I. So if I make minus common from the numerator, this will be Z minus I, and if I take minus from the denominator, and this will be Z plus I. So if I cancel this minus, and therefore our W value is equal to Z minus I by this is Z plus I. So each and every step I have explained. So for getting the solution, so as this is very important, please go through this video for one more time if you don't connect for the first time, as this is also very easy. The first thing is, formula is so easy after substitution. So here is the limit we have to apply L'Hospital's rule, and after making a derivative with respect to n, so minus 1 will be the answer. And here, so after sending these two terms to other side, so here I have sent these two terms to other side and have make a rationalization, and after expanding a minus b whole square and a plus b into a minus b, so here we got this one. So in order to reduce this I, so I have applied combinando dividendo method. So here we got W value, and after simplifying, so we got the final answer as W is equal to, see here, as this is very important, so W is equal to, this is Z minus I by this is Z plus I. So this is sometimes called as Cayley transformation. So which transformation it is? Cayley transformation, as it is very important for GATE examination. And the next question here is, see here, the second question I'm going to explain you. Find the bilinear transformation. Find the bilinear transformation that maps 0, 1, infinity in Z plane into minus 1, minus 2i in the W plane. See here, as the values are also very clear, 0, 1, infinity, and this is minus 1, minus 2, and this is minus I. So I've told you to take W. So here we have to consider this as a Z1, Z2, Z3, and this is W1, W2, and W3. And see, in order to remember, please add Z both sides and W also both sides. So how to remember this formula? So in order to remember this formula, so we have to consider the first 4 points here in the numerator, that is Z, Z1, this is Z2, this is Z3. In the numerator we have to consider the next 4 terms, that is Z1, this is Z2, this is Z3, and this is Z. So this is the unique bilinear transformation formula from the textbook itself. See here. So first of all, I'm considering these 4 points, that is W, W1, this is W2, this is W3, and this is the way I remembered, and I also request you to remember like this, so that it will be very, very easy. So here, so this is how we have to remember the formula here. Now I am going to substitute all the values Z1, Z2, Z3, and W1, W2, and W3. And see here, this is Z minus 0. Clear? So this is a Z minus 0. This is 1 minus infinity. And next one, so this is a 0 minus 1. So this is 0 minus 1. And this is infinity minus Z. And here, this one, this is W minus minus of minus plus 1, and here this value is minus 2 minus of minus plus I, and here this is minus 1 minus of minus plus 2, and this is minus I minus W. Clear? So this is how we have to substitute, and after substituting, here is a logic that, so every time we have to keep Z at one place. So this is Z. Z minus 0 is Z. So this is minus 1. So what is this value? This is 1 minus infinity, and this is infinity minus Z. Clear? So W I'm keeping at one side, W plus 1. And if I make minus common, this is W plus I here. So this value will be W plus I. And next one here, this thing is, so if I take minus common, this will be 2 minus I, and this value is 1. Clear? So I can cancel this minus and plus. This will be 2 minus I. And next thing here is, so this is minus z. So now we have to take a limit, that is limit n tends to infinity. In place of infinity I am writing n here, n minus z, and this will be as it is. So this will be as it is as w plus 1 by this is w plus I into this is 2 minus I. And see here, this value will be infinity by infinity if I apply infinity. In place of n as infinity, this will be infinity by infinity. So what we have to do? So we have to apply L Hospital's rule. Now in place of this we have to apply this is L Hospital's rule. If I apply L Hospital's rule, see what happens. We have to make a derivative with respect to n. See here, for with respect to n, this will be 0 and n value will be minus 1. So n value will be 1 and the rest will be 0. And this value here is minus z. So this is minus z as it is you have to write, and this is w plus 1 by this is w plus I into this value is 2 minus I. So this value is 2 minus I. See here, this value is minus 1 and this is plus 1. So minus of minus, this is going to become, this is w plus 1 and this value is w plus I into this is 2 minus I. If I multiply, this will be z. So this will be z into, if I multiply, send this w plus I to other side. So this will be w plus 1 into this is 2 minus I. And see, so if I still multiply both the values, so this is zw plus zi is equal to, if I multiply, this is 2w, so this is wi and this value is 2 and this value is I. So here, in order to get the w value, what we have to do? So we have to take all these z values common. So here is a w and here is w and here is w. So I'll bring all the w's to one side. So this is zw minus 2w. If I bring it to other side, this will be wi. And see here, this is 2 minus I minus this is zi. So this value is zi. So if I take w common, this will be z minus 2 plus I. Z minus 2 plus I, and this is minus zi, and this value is, this is 2 minus I. See, clear? So I need w value. W value is equal to minus zi plus this is 2 minus I by, so this will be z minus 2 plus 1. So here, if I take minus common, see in the numerator, this will be zi minus 2 plus I. So in the denominator also, if I take minus common, see here, this will be minus z plus 2 and this is minus I. So if I cancel these two, w value will be zi plus this value is I minus 2. And see here, this value is minus z plus this value is 2 minus I. So this is a final w value, and this is how we have to do. And this is also very important. The formula is very important. After substitution also we have to take a limit, and if it is infinity by infinity, we have to apply L Hospital's rule. And see here, after making a derivative with respect to n, so this is minus 1. So if I cross multiply and take w common, so I'll be getting a w value. And both the problems are very easy. So if you go through this video, definitely you can score more and you can solve any problem of this kind. And many videos are solved and vividly explained and uploaded in the playlist. If you really like, please pass the playlist to as many friends as you can. That is the greatest help needed to this channel. Please stay connected, and I'll be uploading the most important videos, and exactly those will be in your question paper. Thank you so much for watching and staying till the end.